This morning, I want us to look at the power of multi-cloud, right? So, when we say cloud, we are not talking about, the cloud up there, right? But cloud in this context is a remote server, right? Somewhere that you can access via a via an internet. So that's basically why you are able to. So that's why you are able to access modern applications flawlessly, and because they have a kind of auto scaling, load balancing, and all that automatically scale the underground infrastructure to match with requests, right? So before cloud, companies usually deploy their infrastructure on premise, and then scaling becomes an issue. And then cloud came in. Some groups of organizations like AWS, Azure, and GCP initially have this infrastructure for their own consumption, right? AWS has Amazon stores and all that. They have um, infrastructure backbone that powers the Amazon stock business and all that. So it goes to a place where you now have extra storage, and they feel like, why can't we sell this extra storage for other services, and then other people, other company, and then they will get paid for it? So that's how this cloud computing stuff comes in, right? So AWS is one of the cloud service providers, and then GCP, then AWS. We have also the likes of IBM and Alibaba Cloud. Many of them are there, right? So now you can deploy your application in a minute. If you need a server, you can have it in less than 1 minute. If you need a storage, if you need a network, you can configure it in 1 second because of the power of cloud computing. Now, that's what cloud computing is all about, right? And then we are now seeing the power of multi-cloud, right? When we say multi-cloud, is when you want to deploy your application. For instance, you want to deploy application. Everything you need to deploy application is available on a particular cloud CSP, that is cloud provider service, cloud service provider, like AWS platform, for instance. Everything you need to run your application is right there on their platform. So why should you use another cloud provider when you can have access to everything to run your application smoothly on one cloud provider? So this morning we are going to look at what multi-cloud is about, and we are going to see why multi-cloud matters, and then the key benefit of multi-cloud, strategies for implementing multi-cloud, and then the challenges that faces multi-cloud and the best practice. And lastly, we'll have question and answer, right? So what is multi-cloud? What is multi-cloud? I've told us what cloud computing is about, right? Now, multi-cloud is the use of multiple cloud service providers like your Azure, AWS, Google Clouds, and your IBM to deploy your single architecture. All right. For instance, you want to deploy a service-based application. Maybe you have an e-commerce, right? You have an e-commerce and you want to deploy it. So on AWS, you already have your you already have your EC2, instance, right? Your VM where you can deploy it. You already have container service running and every other thing that you need to run the applications. For your database, you also have RDS and you also have a couple of different types of services that you can use on AWS to run your applications smoothly. All right. But there is a problem with that, and that problem is what we are going to be addressing in this presentation. So at the end of this presentation, you will understand what multi-cloud is about and why we should adopt multi-cloud to deploy our single architecture, right? So instead of multi-cloud is now, instead of putting your applications in one cloud service provider like AWS and then that's it, you distribute your infrastructure across the service provider, right? That's what a multi-cloud architecture looks like. This is your workload, right? This is your application. You put your application. You put your applications, probably if it's microservice architectures and all that you're running, you maybe put it in an EKS, right? You put it on an EKS here. And then your database is in Google. So they are connecting to database in Google. All right. And you have a messaging system and every other thing, maybe in your Microsoft Azure. All right. And on IBM, you still have a replica of your application in IBM in case, as a fallback, in case anything happens in AWS, you fall back to IBM. So your applications will always guarantee 99.9% availability. This is the kind of architecture modern applications to use today, like the like of your Facebook, Netflix, and all that, that never goes down, that never get into that. You have never experienced issues with them. If you visit them today, they are available. Tomorrow, any minute, they are, because they have this kind of architecture running that, powering that solution. So no matter what, the application is resilient. It doesn't go down. Then what challenges are we face when it comes to running your applications in one cloud service provider? Reason why we are, and that's the reason why we are adopting a multi-cloud solution. All right. So the challenges, one is vendor locking, right? Vendor locking, which limits flexibility and innovation. And let me give you an example of one vendor locking. For instance, we are all here locked in Google, right? You use Gmail. That your Gmail account that you use, you can never change it to another service provider another day in your life again. If you change it, you lose the account. All right. So you must continue to use Google. That means you are locked in there. You are locked in Google. As you continue to share that your Gmail account with anywhere you open your account. That means for you to continue using that Gmail, you must be in the Google ecosystem. You must be within the Google ecosystem, right? So that's vendor locking. Imagine you have an application also that you have applications also on Google platform, and Google has locked you in. You cannot, because you build your entire applications on Google alone, you cannot change some of your service to migrate some of your service to another cloud service provider. So that limitation, even when the other service providers are providing a better service, have better performance, and have a best price, you still cannot move from Google because you have already deployed there. So avoiding vendor locked-in because of lack of flexibility is one of the reasons why we are adopting a multi-cloud based architecture. Downtime in a single provider can cripple service. So imagine you deploy your AWS and then AWS have issues at the time. Before you know it, your application is wiped out, right? So if you must run your application again, then you need to start building afresh on another cloud provider. So that way, if one cloud provider have problems, your applications goes down. That's one of the challenge, right? But if you distribute your application across multiple cloud service provider, if one goes down, it fall back to the second one. Your application will, your users will not even notice that something has happened. Your application will always be there, 99.9% available. Then compliance and data sovereignty issues, right? Some of these cloud providers doesn't have data center across regions of the world, all right? So, and you need to comply with GDPR, right? And then the Chinese also have their own laws that you need to comply with. And these laws requires you don't process user data. Like all the country within the Eurozone, you don't process their data outside the Eurozone, all right? So their data must reside within the Eurozone. If you are using one of the cloud service provider that doesn't have data center within the Eurozone, then you're not going to have customer from that area, all right? So adopting cloud and multi-cloud will enable you to have data center across, distribute your data across multiple regions and process data to comply in a particular region to comply with the data sovereignty issues of that geographical area, right? So that's one of the challenges we are having with a single cloud before adopting a multi-cloud based architecture. So why multi-cloud matters? Multi-cloud matters because it improves resilience by distributing workload, right? So if you adopt multi-cloud, then your application's workload will be distributed across the multiple cloud service provider, and then it's it's it boosts the speed and performance of your application as well, because data become very close. Your data application data become very close to every user that uses your applications, all right? Then performance, enhance global reach and performance. That way, the same way people in China will access your application, the same way it will load faster in China, is the same way it's going to load faster in Hong Kong, in Hong Kong is still close to China, in America, in South Africa, and the like, because the data are very close to them. So they perform because the workload is evenly distributed across the global reach, all right? Then flexibility. The flexibility is what we talked about when I mentioned the vendor lock-in. So you can literally move any of your service from one cloud service provider to another whenever you like, if you choose a multi-cloud approach. So if you think AWS is cheaper and it's performing well, it's better now and all that, you just pull your solutions from Azure and pull it to AWS, and then back for and forth, and whenever you want, you can pull it whenever you want. And then cost, yes. Most of these cloud service providers provide similar services, right? They have almost similar services. On AWS, you have EC2 instance, and then on Google, you have your compute engine and other. It's different name, but the same service, right? And then there are database, Cloud SQL, and RDS, and Azure DB, and storage, and everything. Storage is storage here, storage there, and storage anywhere, right? But they have different names. And if you check the prices for each of these storage or each of these services, they are not the same. They are not the same across service providers. So you can also, if you are cost conscious of your application, you can actually look at the cheaper one, which one is cheaper, and then you use it. All right. Maybe AWS is cheaper when it comes to yes, AWS is cheaper when it comes to VM, right? Infrastructure, AWS is cheaper. And when it comes to analytics, Google is better and cheaper, all right? And when it comes to security, Azure is better and cheaper. So you can look at that way, that okay, my analytics will go to Google, my infrastructure will reside in AWS, and then my security, Google, Azure will manage my security, all right? So that way you are running a, a solutions at a very cheap rate, right? Then key benefit of multi-cloud, redundancy and higher availability. So your application will always be available. You use AWS primarily for your workload, and then you have Azure for failover, all right? So you deploy your applications on one cloud service provider, and you are saying that if anything happened to that service provider, it will fall back to another service provider, maybe GCP, right? So your GCP is used for failover. As the application is running, if a disaster happen, anything happen on AWS, then it will fall back to GCP. Your application will always be running, will always be running. Your customers don't even know that something happened, right? Then cost optimizations. Cost optimization, yes, it helps you save cost because you are looking at different prices for different services, and you're looking for the best price, and the best price service is what you use. And then performance optimization, it also help you to perform it also help to optimize your performance, right? By using the cloud, that is cloud service data center that is very close to your user, right? So some of these applications that we use, maybe Facebook, let's say Facebook and all that, and Netflix and all that we use today, believe you me, the data that you query doesn't really come from America, right? It doesn't come from America's data centers into your mobile phone, right? um is the closest data center to you. Maybe closest data center for AWS here it should be South Africa. South Africa is further than London, right? Yes, I think London should be closer than South Africa. So maybe the closest data center is South Africa. I don't know. AWS doesn't have data center in Nigeria. In African region, they have Egypt, South Africa, I think that's all, and Kenya, I think. So the closest data center is here, is that's very close to you, maybe in London. And then your application, your data doesn't really reside in America. All right. So when you are browsing, it comes from a closed data center. And then they also use cloud CDN. Well, we'll talk about that later. And then enhance security and compliance. You keep your sensitive workload on compliant um, providers like your um, um, cybersecurity, cybersecurity of China's law, right? And the GDPR that says you don't process user data outside their region, right? So every data you are processing within the Eurozone should be residing within the Eurozone, basically, so in the data center. So that enhances security and also compliance. Then strategies for multi-cloud implementations. What are the strategies in implementing a multi-cloud solution? First of all, you need access requirement. Identify your business needs, the workload profiles, and compliance requirements, right? Before you adopt that, right? Set up interoperability, utilize tools like Kubernetes, Terraform, or Anthos for seamless orchestration, right? What this means, right? If you use any of these tools like Kubernetes will help you manage auto scale, right? Manage auto scales, and your applications will be scaling, and your application will not die just suddenly, because Kubernetes will manage the lifespan, the head. If one node or one container, yes, one container is having issues, it will automatically fix it, rectify the issue, create another one. The one that is dead would go down and all that. So Kubernetes have a mechanism that helps your application to stay up and running 247, all right? And then Terraform, on the other hand, helps you to define your applications, your infrastructure that manages your application as if they are code. So you have one source of truth. If the state of that infrastructure is managed by Terraform, that means you, if anything happens, you can still provision same infrastructure for your application at every given point in time. All right. So this is the approach you need to adopt. Have your infrastructure as code, and adopt Kubernetes, so you don't really have to bother about going to manage your applications, scaling, and every other thing, right? And then you ensure you are monitoring your applications and see their performance. Choose the right provider. Consider cost, service, region, and compliance before you choose your provider. All right. Automate everything. Ensures you are not manually configuring things, because the more you are doing it manually, the more you are prone to error, right? But automating it will make it faster and error-proof. So, you use monitoring tools like Prometheus, Grafana to see how your application is performing. Overcoming challenge. When you adopt multi-cloud, yes, it introduces complexity, right? Because you need to cater for one cloud service provider, then the other and the other and other. So it's complex. So adopts cloud management platforms like HashiCorp Cloud will help you, because HashiCorp Cloud is cloud agnostic. So if you can literally manage multiple cloud service from one source, right? Like HashiCorp, right? They have HashiCorp both that manages security and every other thing. Then data transfer cost. You optimize data flow and minimize inter-cloud traffic, right? If your application is residing in one cloud service provider and is communicating with the other service provider before serving your clients, that communication between service provider costs money, data transfer costs comes in, right? So you need to optimize that too. And then skill gap, yes, skill gap is a challenge, because, for instance, I may be very good at Azure, GCP, and AWS, but I don't know much about IBM and Alibaba Cloud. So if you want to do multi-cloud and you have somebody like me, probably, even if Alibaba Cloud is good, because I don't have the necessary skill to deploy to Alibaba, I may not do it perfectly. All right. So it means that you are going to hire more cloud engineer. You have the one that knows better AWS, and then you know the one that knows GCP and all that. So issues like that. So you barely have one engineer that knows all the cloud service provider pattern. Then security risk. You need to implement zero trust architecture and robust identity and access management processes, policy, right? Best practices, right? Best practices: adopt a cloud native approach. Design application for scalability and portability, right? Instead of using CloudFormation, for instance, CloudFormation, CloudFormation is the infrastructure as code tools for AWS platform, right? So instead of adopting AWS platform, that CloudFormation, you adopt Terraform. Terraform is cloud agnostic, so you can use it for multiple clouds. but CloudFormation is basically on only AWS. So adopt cloud native approach and then secure your architecture, encrypt data both at rest and in transit, right? And conduct a regular audit on how your application is working and how your application data flows. You also need to implement infrastructure as code, right? Use infrastructure as code. And then to maintain your infrastructure and your configuration, right? So if anything happens, you can quickly recreate them if you manage it with infrastructure as code like Terraform. And then you continuously monitor and optimize them. And some of the tools available for you to continuously monitoring your solutions is the like of Datadog, New Relic, ALK stacks, Prometheus, Grafana, and the like. When should you choose multi-cloud over CDN Elastic Caching? So I talked about cloud CDN, right, earlier. So the CDN thing is content delivery network. CDN means content delivery network. What it means is they pick static data of your application, right, and save it on edge location close to users distributed all over the world, right? So that your static assets cannot come from the server directly, but from the edge location. That's why some of the application we use today load faster, all right? It loads faster. But elastic caching, on the other hand, is some of your data, right? Some of the data of the application is stored somewhere close to you, right? The difference is that one is static assets, but the other one is your entire application, right? So if you are delivering static and dynamic assets, you can use CDN. Static assets, if you are delivering static assets, you can use CDN. For dynamic assets, if the query needs to come from a database or something like that, then you should be considering elastic caching, right? Ensuring global compute scalability. For CDN, no, because it's only your static solution that is catch in the edge location, right? So your entire data is not there, right? But it's used for, you can do that with elastic caching, right? Data compliance in multiple regions, not for CDN, but elastic caching, yes, right? Disaster recover and failover. In fact, elastic caching is just basically your CDN is basically your static data. So static data and is not really your real data. So basically, you can it's not the core data of your application that CDN handles, right? But what it does is just a static data to load faster for users, and then while processing the underground real data, right? Your underground real data show up and all that. So all these things happen underground without you even noticing. So on this note, we closing this presentation. Do we have any questions for me? Any questions for me?
Yes, sir. Thank you so much, sir. I joined a bit late. I missed my alarm, so I wasn't able to get it from the beginning. But I have this question now regarding the distribution network. So you mentioned something about you having, for instance, let's say Google does better with data, and then AWS does better with this, and you mentioned others. Now, and you also spoke about cost optimization. So this is performance optimization, and then there is cost optimization. And for the
Yes.
cost optimization, um, for the performance optimization, you looked at connecting to servers that do better at certain tasks. And
Yeah.
also the robustness of the server, you looked at distributed networks in case of a downtime on any server. So now,
Yeah.
how do you blend the robustness of the configuration and the cost optimization? Because is it that you will now have to, for robustness, you have to replicate, let's say you have a data server and Google does better with data. So is it to now have an AWS data server as backup or another instance of Google server as backup for robustness sake? Or is that where trade-offs begin to come in? I don't know if you understand my question.
Yes, I understand your question correctly. Um, yeah, if you see big companies like Netflix, cost is not really a challenge. What they want is delivering service to customer, right? In that case, they are looking for best service possible, regardless of the cost. All right. So, but some startups that are still cost conscious, that are still minimizing what their budget, what they spend on cloud solution, will probably look at, well, if Google does analytics best and it's very expensive, and AWS also does analytics very well as well, but not up to Google. But the cost is what we can. The cost is okay for us. They will still stay. They will still stick with AWS, right? It's not like AWS is bad at analytics, right? But you still give it to Google because Google lead in that space. All right. So you need to look at what is more important to you. Is it cost or the robustness of the infrastructure? And then you choose one. For some of these big companies, they don't care about the cost because customer will give them. They will get it from you. You get. So no matter how much they spend, it will still come back to it will still come back to them. So they will look for best service possible. For small company or startup, will rather consider cost.
Okay, that's thank you.
So you're welcome. Any other question? So I have one question for all of you. I've mentioned area of strength for different cloud service providers. If security matters to you, what cloud service provider will you choose? If security is what matters in your solution, right? Security is very, very important. Which cloud service provider will you consider best for this? Michael Adegoke.
Good morning, Mr. Samuel.
Morning.
For if you're focusing primarily on security, the cloud service provider that suits your goal will be Microsoft Azure.
Yes, that's correct. So Azure is leading in that space. All right. Thank you everyone for listening to me. Olabisi, over to you.
All right, thank you very much, Samuel. That was an insightful one. Thank you so much. We appreciate you. Thank you everyone for joining today's section. So that'll be the end of today's session. See you all tomorrow at 9 o'clock. Bye.